Okay, just for time purposes, I'm going to get things kicked off. So hello, my name is Natalie Douglas, and I'm the ZEBx Program Manager. Welcome back to the ZEBx Decarb Lunch series after our little summer break. Today, we're going to be chatting with architect and builder from an excellent West Vancouver retrofit project that exemplifies some great work for aging in place and for meeting zero carbon and energy step codes, even for retrofits, or at least if they were allowed to, they would. To start things off, I'd first like to articulate my gratitude to be able to join today from the unceded traditional territories of the Musqueam, Squamish, and Tsleil-Waututh Nations. I'm also incredibly grateful to the financial support from Vancity, NRCan, the City of Vancouver, and BC Hydro to be able to offer these sessions completely for free. If you're interested in getting continuing education credits for attending today, please see the information that Carrie, my colleague, is going to drop into the chat. Please also use the chat for any purposes, for questions and comments, both for the presenters and for the rest of the audience. We'll keep tabs on the chat and use that to help guide discussion at the end of the hour. Now, just a reminder that ZEBx is part of a family of program areas nested within the federally endowed Zero Emissions Innovation Center, otherwise known as ZEEC, the BC contingent of the Low Carbon Cities Network. So ZEBx is part of the building decarbonization team and can be understood as the main convener and amplifier of content developed by this team. We're the first point of contact for those who are either unsure about how to approach the world of building decarbonization or just want to be updated about everything. Please do check out the B2E for electrification, BC Retrofit Accelerator for retrofits. They also just launched a website to highlight their strata programming, Near Zero for research, and Carbon Leadership Forum BC for embodied carbon. So ZEBx compiles and synthesizes content from all the specialist program areas to promote cross-program interdisciplinary work. ZEEC is also more than just the building decarbonization team. I have colleagues who specialize in communications, economic transformation, granting, and they all work towards accelerating decarbonization. So now, as I introduce my co-host, my colleague Carrie is going to launch the first poll just to give us a sense of who is in the room. Barb Silverthorne is our co-host for today. I'll throw things over to you, Barb, and help us get things kicked off.
Thanks, Natalie, and hi, everybody. Thanks for joining today. It's a great day to have maybe a bowl of soup and some conversation on how deep energy retrofits make your home more cozy. I'm Barb from Capture Energy. We're a small family-run company of energy advisors. We also do mechanical ventilation design, as well as life cycle assessments and embodied carbon work. So I'm super excited to host this lunch today with Erica from EW Architecture and Bradley from Alchemy Construction for the Deep Energy Retrofit project we worked on together over the past 3 years. And I would like to thank Natalie, Roberto, and the ZEBx team for having us share this project with everyone today. And so let's jump right in, and I'll hand it over to Erica to get started.
Just have to unmute yourself, Erica.
Sorry about that. Thank you, Barb. Thank you, Natalie. My name's Erica with EW Architecture. I run a small firm in North Vancouver, and I'm excited to share with you this project. It's a deep energy retrofit and aging in place renovations. Next slide, please. The owners of this house came to me a few years ago and decided to embark on this deep energy retrofit, but a big component of it was aging in place. The couple is in their 80s, and you might ask why someone their age would do this kind of project. Obviously, it costs a lot to build in our community these days, but they wanted to continue to live in their home and age in place, and they also had a vision to do something better for the environment. So we brought the house into the future, and on the left, you can see where we started, and the end result is on the right. Next slide, please. I'll just give you a quick overview of my presentation. I'm going to talk in general terms about why retrofits are important, show a few examples of renovations we've done, and then talk about our approach and the specific needs of the clients and some amazing design opportunities we had. Next slide. So why retrofits? There are over 14 million homes in Canada bleeding energy. And that is a lot of houses and a lot of resources went into building them. We currently have codes for new builds, but nothing exists for existing buildings. So whatever we do is voluntary. And it's amazing when we can do the high performance standard for the new builds, but even more amazing when we can retrofit and turn a poor performer into a high performer. This project has done that, and I hope others will follow. Deep energy retrofits minimize their carbon footprint in a number of ways. We're reducing landfill waste. This next 3 points address the embodied carbon. We capitalize on the embodied carbon already spent in the building materials like concrete, wood, and any other materials we can save, and then we're reducing our load on new raw materials. We are also reducing our operational carbon by improving our building envelope, increasing insulation and airtightness. If you are able to engage a life cycle assessment consultant, then they can help you quantify this information and provide levels of retrofit to help meet your clients' needs and their budgets. Next slide, please. Just quickly want to show you a few examples of transformations. I've come across a lot of people that are intimidated by them. You can see the top row is the existing homes and the bottom row is what we turned them into. Unfortunately, these were not deep energy retrofits that didn't have alignment on the teams and the clients to do that, but I've been advocating for this for years. And you know, turning something in when we've got a good structure, a good foundation, why not? And you're changing the skin of the building, why not add insulation? Why not improve your air tightness? So let's jump into the project and look at the next slide. Our approach is to first reduce the energy demand. If we need less energy, there will be less strain on the grid. And there's a lot of discussion these days about concerns for BC Hydro to be able to handle all the electrification that's going on. So let's start by reducing the amount of energy we actually need and upgrade our envelopes. On this house, we did an entirely external insulation approach. Starting with the foundation, we created our own ICF with GPS, that's the graphite infused polystyrene, both inside and outside the foundation walls. Before we applied it, we installed a damp proofing, put the GPS insulation, and then had a self-adhered membrane outside of that that we could tie into our wall membrane. On the above grade walls and the roof, we used mineral wool, and currently I'm looking at wood fiber as it performs better on the carbon scale, but in this project we used mineral wool. And again, our membranes were a self-adhered vapor open membrane for both the wall and roof above grade. All of this goes to the point of airtightness. As an even more important thing, we're discovering these days in our research that if you have a well-insulated building and you keep increasing the insulation, the quantity of insulation has diminishing returns. And that if you have a big hole in your building, you're actually losing a lot more energy. So our pre-construction lower door test that Barb and her team did, the result was 14 air changes per hour. And by the time we finished construction, Bradley and his team, and Bradley's going to speak after me, they did an amazing job and they achieved 1 air change per hour. And on a challenging form as this one is, with multiple roof pitches, dormers, gables, and hips, and then tying into all of the basement and everything, it's pretty amazing that we achieved that level. I wanted to talk briefly about the wood health because particularly for projects like this, it's incredibly important. This house at 14 air changes per hour had always had warm wood, warm dry wood. So if we had changed that approach and put insulation in the wall cavities and roof and a poly vapor barrier on the inside, or even a vapor open vapor barrier, we're changing the condition and creating thermal and moisture stress within the wood. So by putting everything on the outside, the wood is now warm and dry for the rest of its life. Briefly, just talk about GPS versus XPS. When I do have below grade, I'm going more towards GPS because it's lower cost than XPS, better for the environment, it's lower on the carbon scale, has almost the same R value, and it also has drying potential. They both will absorb water, but XPS won't release it and GPS will. It's too much to dive into more detail on that, but if anyone wants to talk further about that and share research, or if they have better information and can enlighten me on it, you can reach out after the presentation. Next slide, please. Our next step on a deep energy retrofit is to eliminate fossil fuels. And we removed the old oil tank you can see on the left. Thankfully, there was no soil contamination. Then we got rid of the gas. And when our client reached out to Fortis resisted disconnecting and talked about, oh, don't you want backups? And no, the client wanted to completely disconnect. And through a little bit of arguing, they finally got the disconnection. And we also got rid of the old wood burning fireplace where the chimneys created an air path, an opening through our air tightness. So by getting rid of that completely, we had no more chimney, no hole in the envelope. We switched to all electric appliances, induction cooktop, wall oven below the cooktop. We'll talk about that later. And obviously all the other kitchen appliances, heat pump dryer, no hole through the exterior again, no vent is required. And our ventilation approach was using the windows. The client in this case, based on their habits over 80 years of living, of having open windows year round, they decided to forego the expense of installing an HRV, although the contractor installed the equipment so that they could add one in the future in line with the system. We also roughed in for solar. As you can see in the image on the top of the page, we have so much shade that wasn't really an option. Our mechanical systems, you can see the heat pump there, and obviously the electric meter, everything was electric. Next slide, please. So aging in place was a big part of this renovation. You can see the wife and the husband of this couple, they're in their 80s. And we'll talk briefly about the site and building access, the size and reach, and low maintenance materials. Next slide, please. At one point in time, the wife had been in a wheelchair and she's now out and able to get around, but they wanted to create a level transition from their carport. So we created this path, and with a narrow path and having a few bumps between, it's not fully accessible, but we have a level path. And if they encounter a wheelchair in the future, then they can upgrade that path a little bit. And you can see the middle image where that path leads to the kitchen door. And then the most important part is that every exterior door has a flush threshold. This required negotiating with the inspector because NAFS rated doors are required on all of our projects now. We had to explain that we were doing all voluntary upgrades. Our target was step 5 of the BC Building Code, and we achieved step 5. That was confirmed by Barb and her team. And so with that in mind, he basically said to me, if you write a memo and seal it, then I will allow you to do these thresholds. So that's how we achieved this. So we could have full accessibility for the project. We did the best we can, specifying a thermally broken accessible door sill and a door sweep. And then Bradley and his team created a transition piece, a perforated metal sill to span the gap over top of the exterior insulation between inside and outside. The key point here is that we did achieve 1 air change per hour, and we would have done better if we'd had the NAFS rated door sills. Next slide, please. The client had some special needs. She's very small in stature, and you can see on the left, the old kitchen had a step stool by the sink. So we designed this kitchen to meet her needs, and the shelf, the drawing there shows you the top of the shelf is at 4'1.5". And both of the photos here show her standing roughly 5 inches taller than that. So she's about 4'6". So we designed 30-inch counters instead of 36. We had to customize the appliances to work for her, specifying a dishwasher dish drawer to tuck under the 30-inch counter and a 24-inch wall oven to tuck under an induction cooktop. So now, for the first time in her life, she has a kitchen sized for her use. And with open cupboards, now if she's in a wheelchair or her husband's in a wheelchair at some point in the future, there is nothing in the way of access for these cupboards. Next slide, please. We carried that same concept to the laundry room. Again, in the left, you can see a step stool by the washing and dryer machines. And then the laundry machines themselves were raised so that the center line is at the counter height of 30 inches. Everything open, easy access. In the washrooms, we established a flush transition to the shower and a drain at the back wall, so the shower floor is sloped, grab bar, and then also a 30-inch high vanity. Next slide, please. Low maintenance materials were a key element. As an elderly couple, they didn't want to have to deal with repairs and repainting the house, running out of money. They're on a fixed income at this point. So we used metal siding, and that is a pretty obvious choice as a low maintenance material. We also have tile in the showers and bathrooms and certain areas like at the entrances. The coved base was a specific request because they didn't want to have caulking fail, cracked grout or mold build up at the corners. They wanted easy cleaning, nice smooth transitions, and also at the kitchen, a very smooth transition. We had a team weld a stainless steel sink into a stainless steel counter. The wildflowers and natural landscape are something that people might overlook, but this completely eliminates the need for garden tools, lawnmowers, weed whackers, or any other powered device. So they have a very easy landscape to maintain, and it's beautiful. Next slide, please. We'll talk a little bit about some amazing design opportunities because we put the insulation entirely on the outside. The right-hand photo shows what the ceilings look like on the upper floor and on one of the rooms of the main floor. This is all the original framing with the wood boards across. The exception is that the dormers, when we uncovered the ceilings, were not well reinforced, so the engineer stepped in and Bradley and his team reinforced them. But other than that, it's all existing. So we saved all of this wood, and the clients think it's beautiful. We think it's beautiful. It's just an incredible design opportunity by putting the insulation on the outside. The stair in the center photo is the original wood stair that goes to the basement. And Bradley and his team were able to disassemble it, plane and sand the boards and put it back together, and then install a new railing. The living room has now been opened up. There was a wall between the living room and the stairwell area because in the old days, divided rooms kept you warmer. But now with a warm house, opening things up and making the flow better, increasing daylighting by adding French doors, there's lots of light, and it's a beautiful interior. The top one is just a little fun picture of the original phone that was in the basement, and it's still there. All these things also give us some outcomes of the thermal comfort that's kind of obvious with adding the insulation and the air tightness. The air quality is fresh air through the windows, but also there's a filtration system tied in with the HVAC equipment, and it's much quieter in this house than it ever has been before. They can't hear traffic noise. We have triple glazed windows, and they're really loving the peaceful environment. Cost savings over new construction. Obviously, it costs something to do a deep energy retrofit, but it does save over new construction. Some examples are you don't have to pay for the foundation, the framing. The excavation was minimized to the perimeter of the house so that we could insulate and waterproof. And we didn't require a stormwater management plan because we didn't increase the house. So there's a big savings there. No infiltration tanks, no big excavation and backfilling of all of that. And we also saved on the interior insulation and vapor barrier. With that, I think the clients are very happy with the project and looking forward to living their remaining years there. Say thank you to everyone. Next slide. Just some credits to our team and the photos, and also especially thank you to ZEBx and ZEEK and our clients for allowing us to share this project.
Thanks so much, Erica. That was fantastic. Just a couple really quick questions I think you can answer from the chat. Ken was asking if this retrofit triggered current code requirements. You're on mute still, Erica.
There was no code requirement to do a retrofit. This was all completely voluntary.
Yeah. And then the requirements for the door sills. All future accessible buildings will need to meet energy codes. I guess maybe just elaborate a little bit more on how you overcame that challenge, or maybe we want Bradley to speak more about that.
Well, if that's under the 2024 code, that will be different. This project was under the 2018 code. So it was a negotiation. If we, in the future, are required to meet energy codes, it may be that the criteria set has to do with the air changes per hour. If we can still achieve an air change of 1, maybe that's acceptable for a renovation. That's the same level you would need for an Enerfit passive house project.
Yeah. And the last one was if we provided an elevator shaft. And I'm not sure if you shared the size of the home when we were talking, but maybe you could share that. And if
yeah, we didn't provide an elevator shaft. The house was we reconfigured spaces to allow single level living. So there is a bedroom on the main floor. The kitchen is on the main floor, and there's an accessible bathroom on the main floor. All door thresholds are on the main, like exterior doors on the main floor. The exception is the laundry. So if in the future there is an issue with a wheelchair and there isn't someone there as a caregiver to assist with laundry, then there would need to be some accommodation for that.
Great, thank you. All right. Just two other little comments that I was thinking when I was listening to you. One was Alchemy and Erica, because she was also on site a lot and really helping troubleshoot some of the trouble spots in terms of the air barrier. But I'll add for those on that are familiar with aero barrier. Often that is a great solution, but Bradley and his team actually got the air leakage score without using aero barrier, which is really, really impressive. And then the other thing I was just going to say is that was lovely about this project, and none of us see this a lot, but these clients really prioritize building envelope over the interior finishes. And you can see by the Erica's photos that it was still really, really lovely when it was finished, but it was really the envelope first approach, which was great. All right, so I think we can move on to Bradley, and yeah, and then I'll just keep monitoring the chat as well.
Good to go, Bradley? I think he is frozen. Oh, I'm moving the slides, but he is
While
not.
we're waiting for him, I'll just say I forgot to respond. This house is roughly 2,600 square
Right.
feet. And we only filled in about 6 square feet on the south door in order to straighten out the facade. That's it.
Sorry, did I just crash before it went down, or?
Yeah.
Okay, go figure, huh? Technology.
Classic. Over to you, Bradley.
Good afternoon, everybody. My name is Bradley Jones. I'm from Alchemy Construction, and I was the project manager on this project. I'm going to go through a few of the site issues, hazmat, what drove our cost up in this area, and then look at some cost savings that we saw during this project. Next slide. So like any retrofit or like any new build or actually like a renovation, we obviously are dealing with an older house that has things like asbestos, lead paint, dealing with obviously issues with contamination of the site. And so when we originally looked at this site, we were looking at seeing if we could actually save anything, or if we could go into the house and if we could actually, originally Eric was trying to do somewhere we were saving some of the walls and so forth. But as we kind of got into that and we had looked inside, we decided we were going to have to do more of a full demo. And that reason is not, one of the reasons was obviously work safety for our crews, inspectors, because we always have to have a clearance letter. And then at the very end, our clients, they have a house that's, we're not worrying about asbestos or any kind of contaminant, that if they do a renovation in the future, that they're coming into areas where they're finding contamination or things that could cause harm to themselves. Next slide. So we did as I said, we did a complete demo of the inside and outside, and that took us down to the base layer. The roof actually had 3 layers of shingles on it. So they had 2 layers of shingles, and then they had an asbestos shingle layer under as well. I believe that they were trying to save the roof because it was a brand new roof, but it was just becoming too hard to integrate that roof into the tightness. And as Erica was alluding to, the clients really wanted to get this, they really wanted to work on getting an air tightness and so forth. So removing that layer on the roof allowed us to now work with a skeleton that we could actually get a great seal on. And I'll be showing that as we're coming up. So in this, we also removed obviously there was original aluminum on the siding, which we recycle. There's products being wasted, but in a regular demo, all these products are having to be abated anyway. So there's no sort of cost savings or loss in this part of the job, because these things would be taken off because of their contamination and have to be taken away for different sites to be taken because of their contamination. Next slide. So the big area which we found that was really hard to control cost and was a bit of a budgeting nightmare, let alone a nightmare for us building, is the roof. And the roof here, because it had, as you've seen the pictures, it's a 12-12 pitch. It has dormers, it has hips, and that makes everything difficult because we are trying to attach our foam, our rock wool insulation to this, but also our sheathing through all this membrane. And I'm going to go through all the layers because that'll give you kind of a bit of an idea. So if you want to go to slide 4. So I've only got 6 pictures here, but there's actually 7 layers of this roof. The first one was, as you saw in the original slide, we had the original strapping of the roof, and so we put a layer of 1/2-inch ply so we could build off of. Future recommendation, I would have done 3/4, just so we had some structural integrity. We were planning, which we did, we screwed through the 1/2-inch into the strapping of the roof. So that's what we used as to hold everything. It was the strapping of the original roof, because that was 1x4. So we had a layer of 1/2-inch ply that went over the whole roof. And again, that's, sheathing a roof, there's time and cost of that. Followed by the roof membrane. We went with the Adiro product. This was something that Erica suggested we use. It's the Adiro 3000. this is kind of our first time. I wasn't a big proponent of this job, I'll have to say. I was a bit kind of not too happy. I was not happy. I thought we should probably push the house over and start new just because of the cost of doing all this. So I definitely, for me building this and working on this project, I was basically, I was somebody who actually was definitely come along with it at the end of it. And it was a great project, and I'm happy that we did it, and definitely saw the benefits of actually doing this project. So as I was saying, the Dero 3000, which Eric had recommended, it's quite pricey to roll. It's a peel and stick membrane. The one good thing about it is, well, I guess the two good things, it's acrylic, so it's water-based, so you're not dealing with chemicals. It's very easy to malleable, and if you make a mistake applying it, you've got some time to readjust it before it actually sets up. It kind of sets up, I think, within 24 hours, and then it does not come off. As having this membrane on the roof gave us that one air exchange, because we were able to have that whole membrane attached to our wall membranes, attached to our basement foundation membranes. So we had this whole sealed building. So our membrane's on the outside of the house. So there's no, we're not worried about future construction inside where someone can actually damage that membrane. So even with our construction inside, where if someone's poking around in the walls inside, our air membrane's completely on the outside of the building, and it's not affecting our air changes. So after that roof membrane went on, we had our insulation, and we had 2 layers of 4-inch rock wool. So we've got 8 inches of rock wool insulation on that roof. I think it works out to R37 continuous. Again, because we've got all these hips and everything, we're cutting this with bread knife and attaching it with GRKs. At this point I think we're using 10-inch GRKs, and we get even longer as we go forward. So, and because that corner, and because of these hips, some of these corners now are basically just rock wool corners. They're not actually structural corners. So that's why we had to build the whole roof on again and go for a cross strapping, because we needed to get airflow through the system. So we did a 2x4 cross strapping. And again, this we're screwing back on with GRKs. So now we're using 12-inch GRKs to go through 3 inches of structural material, through our 8 inches of rock wool into our 1/2 inch, but trying to hit our 1x4, which, as I said, it would be easier if we use a 3/4 membrane, 3/4 sheathing, followed by a sheathing on top of that, and then our roofing paper and shingles. So that roof became quite a complex. Like, as you can see, all the steps that were involved. There's, cutting involved. Just the labor cost was absolutely enormous on that. It would have been easier if we had more of a flat roof, or some roof that was just a standard 12-12 pitch with no dormer. So that's kind of where our biggest cost was on the build. And next slide. So our cost savings. As Eric alluded, the clients were big on the simplicity, so that really helped us. The bathrooms and plumbing. We didn't have no interior insulation, so we saved because of all our insulation on the exterior. We didn't have interior insulation. And now our exterior walls and all our walls inside, because we pushed everything to the outside of the building, we can use for services. And I'll show you move to the next slide. So with the bathrooms, Erica alluded that it was a 1.5 bathrooms originally. We went with, on the main floor, we pulled a full bathroom in, a 3-piece. It was a shower, toilet, and sink. And the top floor had the same thing. These are both wheelchair accessible, but very simplistic: tile floors, tile walls, grab handles. And, but each floor has one of these 3-piece units. We didn't add 3 or 4 bathrooms, just 2 bathrooms in the house. And I think that kind of goes to savings again, because the more bathrooms you're putting in, the cost of fixtures, the cost of just rough plumbing, your electrical plumbing, and as well as your property tax, since they charge you for each additional washroom in your house for tax purposes. If you can keep that to a minimum, it saves you on cleaning charges as well in the future, but it does limit your cost. And I was alluding to as well that all the exterior walls, because we have our exterior insulation, we're able to use them as chases and runs. We ran our drainage pipes in the exterior walls. We ran our water pipes in the exterior walls. The center image is actually this bathroom upstairs. That's our exhaust fan for the bathroom upstairs. That's run in the exterior wall. So all of our walls now became accessible for chases. And anybody who's, I'm not sure who's built a builder on this this group that's watching, but designers always like to change things as we're moving along in a project. So they'll actually ask for, to move a plug or some type of device in the house. And those becomes, and especially in exterior walls, we're always dealing with, it's messing up our vapor barrier or our air barriers. But in a situation like this, it's very easy just to open the wall and move a switch or a plug. I mean, obviously there's drywall repairs and so forth, but we're not ruining the integrity of that air membrane again. And obviously makes all our, we did have a few, because we're doing it, chasing down wires. Sometimes, electricians will miss a wire or they forget to back lead into a box or so forth. So being able to just fish wires through walls like this is much easier as well, not pushing insulation around and then again damaging the vapor barrier or your air barrier because it's on the outside. The other big thing of this is that because our exterior insulation and everything happened on the outside of the building, is we're able to have everybody work in this house while it was warm and dry. And we basically heated this whole house with a 1500 watt heater through the whole build throughout the winter, and it ran intermittent. Now, it wasn't a balmy 20 inside, but it was 15 degrees Celsius inside, which, I mean, anybody who works in Vancouver where it's damp, I mean, that makes all your workers all excited because they can sit in the dry house, work without, water dripping on themselves. And we're not trying to get wood dry at the very end before we bore, because this wood, as Erica alluded to as well, is dry from the inside, and we're not preventing it from actually ever actually being stuck in a plastic bag, so it's not going to be damaged for the future. I guess the other thing is to saving costs is I think the biggest was the clients with we had no secondary kitchens, no secondary laundry facilities. I know that there was a question about laundry facilities that there is in the basement. Obviously with new washer and dryers, these clients are big on air drying their stuff outside when they can. So the washing machine is pretty much the only thing that would need to come to the main floor for them, because the dryer they just put in for days of very wet days, I guess, like today. And I think that's all I've got. So next slide, I think we're at the end of my presentation. I am. So I just wanted to thank everybody. I actually wanted to thank Erica for bringing us this project. I know that it was definitely, there was a lot of on-site meetings about how to make things work, which was definitely, and with something like this is a challenge, and that's, but with Erica and Barb helped us up as well, just to be able to get these problems solved.
Thanks so much, Bradley. A few more questions came up in the meeting chat. I think we have a little bit of time. And maybe, I'm not sure who best can answer them, but maybe you guys can both pitch in. One that was interesting was wildfire risk a consideration, especially with the cladding decisions?
Well, I mean, we're not, the requirement in that area, we don't worry about wildfire. I mean, we're not in a fire zone. Obviously, the rock wool you can use for fire safety as well as the metal cladding. So absolutely. I mean, we're not really, I guess you could.
It wasn't required, but
it was not required, but it's definitely a strong feature for it. Yes.
Yeah.
It was more from a low maintenance point of view. The client wanted the metal cladding. I mentioned earlier that I'm looking at wood fiber now. I'm doing an assembly project where we really want to look into the fire ratings and fire resistant properties of the wood fiber insulation, because from a carbon perspective, it's so much better. But if we discover that it's not meeting the criteria and we have an assembly occupancy of over 300, then we want to make sure people are safe in an exiting environment. So, but the things we're concerned about with insulation is air permeance. So I don't want to put foam on the outside of the building. Everyone probably heard about the case in Britain where the building was engulfed in flames instantly, and it was foam insulation. So we're looking at taking that into account. And in this case, you know, we did the mineral wool.
Thanks, guys. 3 questions about the roof, which is funny because it was such a big part of the challenge. First one was, Bradley, was there a lot of extra framing required for the extra weight of the exterior insulation?
So the roof itself, like, I mean, obviously we have that, we have obviously our engineer on for that. It's an existing roof. We did for all the, when you saw the picture of the original roof, we did GRK all that roof membrane back to the structural integrity of the walls. So there's obviously hardware that was used, but the roof load, I mean, the insulation it's not for the engineer's calculations, it wasn't a huge factor for weight, but we did do mechanical fastening we added mechanical fastening for everything inside that we could see. So like I said, if you see that cross strapping in the ceiling and so forth, we did all GRK that material because obviously it probably just had 3-inch nails in the original design.
I'll speak to that a little bit. The existing roof was able to handle the load of the additional materials. It was really just the dormers. Bradley can speak about when we took off the interior finish. The dormers really were hanging by a thread. There was nothing there supporting them. So that's the only structural upgrade we had on the roof system.
Okay. The next part of that, a 2-part question kind of, was wind lift also a consideration?
Well, I'm not an engineer, but I mean if we go back to the picture of the house, there's actually no we actually don't have any overhang on the roof, so there's actually the wind would be, I guess it would be for, I mean, like that would be an engineering question I guess we could ask about, but
yeah.
But if the engineer is designing everything to meet code, they're looking at all the lateral forces, wind, seismic, everything to meet code. So it's not just the dead loads. They're also doing the lateral load. So if he's checked it and he's signed off on the structural design, there was no issue with wind loads or seismic. We did have some, where we took out walls, we have some new parallel beams and some new parallel, was it parallel columns or did you use something else there?
We used parallel beams and parallel columns, yes.
Yeah.
But we did as much structural upgrade as we saw fit with tie downs and so forth, and we even anchored the house because the original house was never anchored to the foundation, so we did bolt downs and we anchored as much as we could. Again, there's no real requirement for that. I'm not saying you shouldn't do it. I'm just saying that we did as much as we could see, and we did obviously what we changed. We actually added the structural integrities to.
And that was another advantage of taking it back to the frame, is that you had full access for the walls to be able to add the hold down hardware. And the existing foundation, other than some water damage because it hadn't been waterproofed properly, and there was some spalling off on the inside of the foundation. Other than that, it was perfectly sound. There was nothing structurally wrong with the foundation. So we were able to add the hardware, and the engineer was happy with the solution.
Great, thanks guys. Erica, this one's probably more for you. Was a metal roof ever in consideration?
Yes, it was. It would have been preferred, but at 80 years old on a fixed income, they saved money on the roof and they saved money on the HRV.
Yeah.
And like Bradley said, they had very simple tastes. They saved money on cabinet doors. They didn't want them. They wanted everything open. So everywhere they could save, they did. Thinking about, you know, in our culture these days, there's, especially with a lot of media that we get, everybody wants what the next person has or better. And these people weren't about that. They were about living simply, living with what they need, not with, I want stuff.
Yeah. And it's, some hard decisions were made and a lot of conversations around things like that, because it's incredible to me how much was done with the budget for this project. And it's really nice to showcase a project that is a deep energy retrofit like this, that didn't have a it wasn't I don't know. I don't know how to say it. So it was, a modest home in terms of West Van property. But it did require some decisions, and ideally, yes, it would have had an HRV and a metal roof, but there had to be give and take at some places.
I wanted to talk a little bit about the gas, because I've heard a lot of people say, what about gas backup? You can talk about what happens with the equipment, Barb, but I'll just say that if you think about our area, how long do power outages actually last? And if you have a well-insulated house, are you actually going to get cold in there? I had some clients years ago in Lions Bay, and they would have power outages for 10-day stretches. They'd been in their house for many, many years. And so for them, they felt like they really needed a backup, and we did a propane backup for them. But in this case, in the Greater Vancouver area, we really don't need a backup. You can talk about the equipment, Barb.
Yeah, I think the other thing is just the misconception that people still have, like, all the higher performing gas furnaces, they all have electronic ignition anyhow. So if the power does go out, most of your gas appliances aren't working anyhow. But yeah, and now with cold climate heat pumps in our climate zone, there's absolutely no requirement whatsoever to have a supplementary or secondary heating source. This is a good one. With the removal of gas for heating, was an electrical service upgrade required?
No, we still have a 200 amp, don't we, Bradley?
Yeah, we upgraded to just a 200 amp system. I mean, that's usually required we did a whole rewire on the house. So we had to move the location of the power. So, I think even for insurance purposes, you need a 200 amp. So 200 amp system is pretty basic use. When you say upgrade, we had to get a new service connection, but it's mostly I guess it is a service upgrade, but we're doing reservicing.
It was a 100 amp panel before, because it was an old house.
Yeah.
But regardless of doing the deep energy retrofit, they would make you upgrade to a 200 amp panel for a non-deep energy
Yes.
retrofit.
It's kind of irrelevant. Yeah, they would ask for your.
But we didn't have to go to 400.
No.
Two more detailed questions. One, Erica, we didn't have to meet new code for building envelope, but what about like radon? Or did you guys do radon testing?
Did not do a radon test, no.
We do. So just familiarity is, obviously because we did pour a lightweight in the basement. We did put a poly barrier down, as well as we put a dimple mat to do some ground breakage. And we also have air circulation in the house because we have a forced air system. So we're moving air out of that space. So if there is some radon coming in, it would be mitigated.
And you tied that membrane into the walls. So
Correct.
that was also, again, a contributor to the air tightness, but it helped deal with the soil and gas. Soil gases.
Correct.
And Wally had a question. Oops, my chat keeps bouncing around. Something about the screws and where is it here? Do you worry about heat conduction of the long screws? Not totally?
Well, the long screws don't go to the exterior of our they only go to the 2x4s, so they're actually underneath the cladding as well. So the cladding is attached to our rain screen or the sheathing on top. So they're not, I guess they could move, they would move heat, but not enough to be worried about.
If you were doing a passive house, you would calculate all the screws as part of your thermal bridge. They have a minor impact. We didn't go through certification again. Client would have loved to, but at 80 years old, didn't want to spend the money on going through all of that. So yes, screws can create a little bit of a thermal bridge, but we did not calculate it.
Great. I think that's all of the questions. I don't know if you guys have any kind of final
I think I
comments.
just wanted to jump in here, Barb, maybe as a final little discussion point.
Mhm.
I think the point that Bradley brought up about there being initial tension at the start of trying to figure out, like, is this actually worth it? I kind of want to just expand on that and talk a little bit about how we're so used to demolition, even not even just like deconstruction, but demolition, and just start over. It's easier, it's newer. Do you think we can get to a place where, companies are feeling good with prioritizing renovation? This also kind of requires a regulatory shift and probably a cultural shift. But from your experience as the builder, are you, open to working on more? Has this been an overall positive experience?
For me, obviously, like it's, definitely in a renovation, I know that there's people think of the cost there, obviously, because you're dealing with an original building, and you're trying to get it back to something that you can actually reuse again. I think, I definitely would like to have something more. I mean, it was great to have this project and be able to work on it. I think, a lot of homes that are out there probably could actually, because they're, especially in Vancouver, where they probably are in their FSR, they're already maxed their FSR, they might actually be beyond their FSR. It might be proactive to use that size and change some visual aspects about it, but use the same building.
I'd like to talk a little bit about that. I've been prioritizing renovations. Probably 90% of my business ever since I've been in practice have been renovations. It's my vision to do something better for the environment. And this has been my first chance to do it. I remember 8 years ago sitting down with a huge binder, meeting with a contractor I couldn't get on board. I had read 300-page RDH reports about exterior insulation and all of the calculations and everything like that, and started doing RSI calculations on my own project so I could understand it and advocate for it. And it's all I want to do because I feel like it's wasteful. Why throw all of this stuff in the landfill? And landfills are emitting methane and damaging our environment as well. Because of the age of these clients, we had very frank conversations about going down this path. They do have a fixed income. Bradley was involved in those conversations. I was involved, and Bradley's boss was involved. Said, do you really want to do this? It's going to cost you something. And they said, yes, we do. We really do. So I wish we would have more clients like that and we could get the word out more so that all of our teams are interested in doing this, because most of the buildings, even a few weeks ago, I had someone come to me and say, I want to tear this down and do a new build. And I said, let's talk about that first. Let's look at your structure. Is the structure sound? Can we adapt the spaces to the use? I have encountered projects where there's a wartime 1920s house that was quick housing put up, 6-inch unreinforced concrete wall, 6-inch slab. That's it. So we couldn't really save the foundation because there wasn't enough structure there. But when you can save the foundation, when you can save the framing, then that's kind of your baseline. And it's pretty much like building a new house after that. I'm working on a deep energy retrofit of a church right now. And there's going to be a lot more that we save. Wood paneling, glulam arches, wood deck ceiling. We're going to deconstruct part of the project and reuse some of the materials from that. So, that's kind of my mission.
Well, I think on that heartening note, we can close up. Thank you so much, Bradley and Erica and Barb, for offering your time and your expertise on this important topic. And honestly, I'm sure the owners are probably not on this industry-focused webinar, but please do pass along our thanks for allowing us to learn from this project collectively. So I will just highlight a couple other events that are coming up. 3 other webinars from the ZEBx team and an in-person event coming up soon. So B2E has a webinar coming up, how demand response can support electrification. That is on the 3rd. We have another decarb lunch because we're on this 2-a-month train now, highlighting the Marpole Community Center, hitting both passive house and a 40% embodied carbon reduction. So very impressive project. The Strata Energy Program from the BCRA, the BC Retrofit Accelerated, recently launched, and there's going to be a webinar on that as well. And there will be a 5-year anniversary for CLFBC. So we talked actually a lot about materials and consumption today. If you find this to be a really empowering space to be in, I highly encourage you to come to this event. A lot of really great people, well-connected networking opportunity, and just overall celebration for all of the really great work happening here in BC. So you're very welcome to come to this. And just wanted to conclude with a big thanks to everyone who attended today. This building exchange is as good as the folks that engage with it. So I'm immensely grateful to all of you folks for being here today and engaging in such a lively manner in the chat. It makes it a lot more interesting and helpful. So thank you all.